So we're going to look at all of the steps to factoring and focus on a couple more than others. Things that you may or may not be aware of, the new ones, sum of the cube and difference of the cubes, factor by grouping, and rewriting something as a quadratic or in quadratic form, or recognizing that it's in quadratic form. That can give you another way to factor ones where you don't have a nice power of 2. All right? But again, it's all about recognition. So you're going to see factoring trinomials. How do you factor a trinomial? Doesn't matter to me. But you've got to be able to get down to 2x plus 5 and x minus 4. How do we factor x squared plus 8x plus 16? That's a PST. We should all be able to do that. Difference of two squares, first plus second, first minus second. This one right here, most important, the common factor. Because if you don't take out what's in common first, any of the other things that may be there, you're not going to find them. And we'll talk about sum and difference of the cubes specifically in a moment. But again, right? This is a big deal. This is the one that you're going to forget. You think I'm trying to make this funny. I want you to remember this. You're going to skip greatest common factor. Every one of you in this room, myself included, will skip greatest common factor in a problem between now and the next couple weeks, probably before we finish this chapter. And it's not because you don't know to do it. We all know we're supposed to factor out what's in common. Why are we going to screw this up? Well, because you're going to see something else. Oh, look, a difference of the squares. Or, oh, that's a trinomial we can borrow from the clouds. You've got to factor out what's in common first before you start going to anything else. What's common here? You've got to pull the x out and then look at what's left and factor that. And again, how you do that, it really doesn't make any difference to me. Okay? X minus 6, x plus 2. I don't care how you do it, but I think you should be able to do these relatively quickly. And what gets frustrating is watching you, like me, it's frustrating when you say, oh, it's not factorable, but you skip step 1. What's common here? 3x. So we pull the 3x. Then you get to a nice quadratic, theoretically, that happens to be what? PST. And honestly, I expect you all to be able to do that. If you are thinking in your head right now, I can't do that, what are you willing to do so that you can? Are you willing to come in and get help? Because, like I said last week, we only have 1 or 2 people in this room who come in for help. And if you're not willing to come in and get help or go online and look at the notes at least, then I think you're sending a much more concrete message for me, that you're not willing to do that, you're good where you are. What's common here? And you'll be left with g squared minus 16, which is the difference of 2 squares. Okay? This is a big deal, this first step to factoring. If you don't know borrowing from the clouds or PSTs or difference of 2 squares, you've got to come in and get it. You've got to print out the factoring review and come in with it in your hand and say, Mr. Locker, I'm really struggling with my factoring. If you continue to not do that, like I told you, this is your last chapter. After this, you won't be able to bounce back. We're going to go through these quickly. If you need help with any of them, let me know. These are online.
I think there was a problem once there was 8g squared minus 32 or something. Would you want us to take out 8 and just make it 8?
G squared minus 4? Sure. It wouldn't be a difference of 2 squares if you did that.
Or g squared
you have, you said 8g squared
Yeah.
minus 32.
Yeah.
If you take a 2 out, you would get a difference of 2 squares, but it still has a common factor, which means your final answer would have common factors that need to be factored out. If there's an 8 that goes into everything, you have to factor the 8 out. That's going to give you a difference of 2 squares, right? G squared minus 4 is a difference of 2 squares also. Nothing wrong with that, but yours would be incompletely factored if you only pull the 2 out. GCF, what's it stand for? Greatest common factor, not the goodest common factor, or get a common factor, or greatest common fail, or garbanzo. I'm sure we could come up with something. Okay? Difference of 2 squares, something squared minus something squared, first plus second, first minus second. Okay? The third step, perfect square trinomials. I showed you a variety of ways to look at them. You can go online and see these again. Half of b squared equals a times c, or the square root of a times c equals half of b, or this is what I use, root a, root c. If that product equals half of b, I know I got a PST. But you need to be able to recognize them for sure on site. You do not want to have this be something you borrow from the clouds with when it's a PST. So when you factor it, the square root of the first sign, the square root of the last, wrap it in square. So again, perfect square trinomials, we should be pretty good at. In factoring trinomials, they're not PSTs. You can borrow from the clouds, diamond, box, guess and check, Harry Potter, whatever. Come up with something that works for you. Come up with a method that works for you and do it every single time. Right. Does anybody have a question on those first 4 steps of factoring? First 4 steps. But if I think you're all pretty good at it. I think some of you waver on this, and I know that some of you can't tell these, but you can catch them here. If you want to get to where you belong in this class, you've got to know all 4 steps. So if you don't know what a PST is, you can't ignore it. You're ignoring a problem that doesn't go away. And if you don't have a method for factoring trinomials, if there are anybody who hasn't got to that point, you need to get a method. You need to come in if you need help. I can help you with borrowing from the clouds. I can help you with guess and check. Diamond and box, I'm really not all that well versed in those. Okay, the next one is a sum and a difference of the cubes. Get that going, huh? That's impressive. I used to do it this way, but it's not as, that's a solid structure right there. It's fantastic. Okay, so a sum of the cubes. It has to be something cubed plus something cubed. In order to recognize these, you're going to have to know your perfect cubes. You're going to want to be able to recognize those on site. 1, 8, 27, 64, 125. Those are the first 5 that we talked about a while ago. You might want to throw in a 216 and a 343 on your list, just to have a few more at your disposal. And when you see a variable cubed, check your numbers. It's probably going to be one of those. And again, you may need to factor out something in common first. So the factoring pattern, once you recognize, hey, I got a sum of 2 cubes, is the first plus the second. Then the first squared. So whatever you write here, square it, put it here. This was a plus, just like this is a sum of the cubes. That's a minus then. And then you multiply these 2 together. It's not 2AB like the trinomials, a PST. It's just AB here. And then whatever you wrote in the second spot, square that. That's the square. This trinomial here is never factorable. When you do a sum of the cubes, when you factor and you get the binomial times the trinomial will never, ever be factorable. Unless you did something wrong and missed step number 1. And then you could have that possibility. But if you did that, you're not going to catch it here. This is the pattern for a sum of the cubes. It's the same pattern for a difference of the cubes, except that when it's a difference, the binomial is the minus, and the trinomial is a plus. So whatever you start with a plus or a minus, sum of the difference of the cubes, the binomial gets the same sign. And the first sign over here is always opposite of what's in the binomial. So if this is a minus, that's a plus. If this is a plus for a sum of the cubes, that's got to be minus. When you square something, it's always positive. The third sign can never be a negative sign in that binomial. And again, the trinomial is never factorable. One of the ways, sometimes you'll see some books do both formulas together. So you say a cubed plus or minus b cubed. So plus or minus, here it's plus or minus, and here it's minus plus. So all the signs on the top would go together, and all the signs on the bottom would go together. So if you'd rather just write it in one format, you could just write it. This is another pattern. You just really going to want to memorize it. And we're going to power through a bunch of examples with this. This is the first of the new things for the day. I think some of you have seen sum and difference of the cubes before. We need to just visit it again. All right, so let's look at the pattern. So x cubed, that is a giveaway that you have a sum, in this case a sum of two cubes. Hopefully you recognize the 125, and you say, okay, well, the thing that's being cubed second is what? 5. And I'm not suggesting you have to rewrite it like that. If that helps you, so be it. This is a sum of the cubes. So it's going to factor first plus second, first squared, the product of these two, and then the second squared. Remember, it's not twice the product. It's whatever these two together multiply, that goes in the middle. If this is a plus, the binomial is plus, trinomial is minus plus. And that's how it factors. What do you know about the trinomial?
It's not factorable.
It's not factorable. Ever. It's not going to stop some of you from factoring it. But I'm telling you right now that that trinomial is never factorable. Save your energy. Put a little star next to it. Don't factor it. I multiplied these two together, and then I'm just following the pattern. If this is plus, this is plus, this is minus, this is plus. Here's your pattern right here. So you have a cubed plus b cubed, a plus b, x plus 5, a squared, x squared, minus a times b, x times 5 or 5x, plus b squared. This is always a minus when this is a plus. Okay?
Isn't b squared 25?
That is a 25. All right. Penmanship issues. Okay? Y cubed minus 2 cubed. Y minus 2, first minus second. First squared plus 2y plus 4. This is a difference of 2 cubes. This is all about recognition. Do you recognize the difference of 2 cubes? If so, it's a recipe. I love recipes. If you can just follow the recipe, it's great. Yeah, it's perfect if you have a recipe. My grandmother, she was a phenomenal cook. And some of the things that I still made for my kids when they were growing up, I made because I had them when I was a kid. My grandmother was crappy with recipes. If you stood with her and watched her cook, you would go nuts. You know, whether it was cookies or pies, she would pour into her hand, okay, that's good. And then pour the next ingredient in. And flour with the handfuls. Not a cup of flour, handfuls of her little hands. It took me years to get recipes from her. Years. Thank God before she died we were able to do that. I'm a recipe guy. I need 4 cups of this, a half a cup of that, a teaspoon of this. I'm good with that. That's why this is so easy. Follow the recipe. Try this one. Tell them. Boom. You got to take out what's in common first. You pull the 2, then you get the sum of the cubes. But if you don't pull the 2 out first, you're going to write, oh, that's not factorable. 2's not a perfect cube. We're done. But if you pull the 2 out, then it's just recipe math. I've never had a student who memorized the pattern who can't factor these. I have lots of students who refuse to memorize this pattern right here, and they come up and they say, geez, I don't know how to factor this. They don't remember this pattern. When you don't remember this pattern, it's hard to factor a sum and difference of the cubes. Try this one. Lexi, what's in common? 5. When you pull the 5, Julie, I'll post these notes for you if you want them in the video if you don't mind too. See you tomorrow. Good luck. Bring me something. Now, again, I'm a big fan of rewriting this, especially when you have a coefficient in front of, in this case, the v, and I would call that 2v cubed minus 5 cubed. Most of you, not so much on that rewriting, because that takes an extra time. That's one less text you could send today. I mean, think about it. I know. Ignore this 5. 5's just going to be part of the answer. What goes in the binomial? Minus 5. And then we square it plus nv. And don't forget, 5 is still part of your answer. If you factored it out, it's got to be part of the answer. Josh, give me that look. Sure? Scribble, good?
Yep.
Okay, remember the pattern. So here's our pattern. A cubed minus b cubed. So whatever a is, we square that. Then we multiply these 2 together. That gives you what's in the middle. And then we square the second one. And it's a minus plus plus. So the first thing goes here, the second thing here with a minus. Square that. That's this. Multiply those 2 together. What do you get? That's the 10b. And then square the second one. That's the 25. Is this factorable? It's like a PST, doesn't it? What do you mean no? Of course it looks like one, but it's not. But it does look, give me a little bit.
It looks like this.
It does look like this, but it's not.
So if it's a plus, then is it minus plus in the, I'm talking about the formula?
Whatever is here goes in the binomial.
Right.
The next sign is different.
Okay.
And the third sign has to be a plus.
Okay.
These two signs right here are always opposites.
Okay.
And whatever's in the binomial is what's in between the two terms to begin with.
Okay.
Okay? Everybody good? All right. I know you can combine like terms, but I want you to see what's in common here. What's in common in this one? X. What's in common in the second one?
Y.
In the third one?
These should be in parentheses.
The x plus y is in common, and here it's x plus 2y in common. Right? Now, years ago, literally 20 plus years ago, when we would teach Algebra 1, we used to teach factor by grouping. And the factor by grouping there was tricky. You guys, and I'm telling you right now, the secret to this in this course right now, every single problem they give you that is a factor by grouping factorization is going to be done the same way. You don't even have to guess how to group them. It's always the same. You're going to group when you have 4 terms. It's really 4 or more, but only in this class we'll be grouping 4s. You will always group first 2, last 2. Always. So when you have 4 terms, it's not anything trinomial, it can't be difference of the squares, all that other stuff. We're going to put parentheses around the first 2 and the last 2. And take out what's in common in the first parentheses. What's common in there? R squared. So we're going to pull out R squared, and you're going to be left with, in this case, R minus 3. What's common in the second one? 6. And when you pull the 6, you'll be left with, see how the R minus 3s are identical? If that's true, then this is going to factor by grouping. If you pull out the common factor, the R minus 3, that's what's in common. Who's left? R squared plus 6. That's how it factors. Can R squared plus 6 be factored further? No. So we're done. Every single one in this book is first 2, last 2. We used to do like first and fourth, second and third, first and third, second and fourth, all different kinds of combinations. And we used to do more than 4 terms, so you'd have to do first 3, last 2. First and last, middle 3. It was just crazy because there's so many options on what you have to try. You guys, I am telling you right now, I swear on the book of Algebra 2, it will be first 2, last 2, or it's not going to work. You need a pillow, blanket? No?
Why wouldn't it be R minus 3 squared?
It's a great question. What's in common there? If you pull the x out, what would you have left? 4 plus 7. Not that you would ever do that. You would just combine them right from the get-go. How come we didn't write x squared there? The reason why it's easier to see here, when you distribute it, everyone gets the x. Same thing is true here. When you distribute r minus 3 times r squared, you would get r squared times r minus 3. R minus 3 times the plus 6 would give you 6 times the R minus 3. The reason why we don't do it is because it's common and it went in front to be distributed later. Okay, great question though. Everybody good on factor by grouping?
Weren't we going to do anything else?
Right now I want to know if you're good with where we are.
Okay.
I don't get where you got the r squared in the first part.
This one?
Yeah.
In the first parenthesis, what's in common between r to the third and 3r to the second? Do you agree they both have r's?
Yeah.
Do you agree that the lowest power between the r's is r to the second?
Yeah.
That's where the r squared comes from.
Okay.
I couldn't take r to the third out because there's not 3 r's here. It's only r squared.
Okay.
So it's the greatest common factor in the first parenthesis.
Oh, alright.
Just like here, what's in common is a 6.
Oh, I see.
And we pull the 6 to the front, that leaves you with 6r. 6 times 3 is 18. You seeing that?
Yeah.
Remember the explosion?
Yeah.
That's what we're doing. We're taking out what's in common.
Okay.
But we're doing it in 2 separate parentheses.
Alright.
How many terms? Is it a PST? Difference of 2 squares? Factorable trinomial? None of that's going to be true because it's not any of those things. If there's 4 terms, how do we group them? First 2, last 2. It's always first 2, last 2. Okay, it will never be anything but that in this class, I promise you. What's common in the first one?
X squared.
X squared. Pull it out, you're left with x plus 6. What's in common in the second one? Also x plus 6. If these two aren't identical, it means it can't be factored. Sometimes that's going to happen. It's just a not factorable, fourth expression. If we pull the x plus 6, common factor, who's left?
You have to do the x plus 6 first.
When you factor out something in common, where do you normally put it? Well, you've been factoring out what's in common. 3x squared plus 9, for example. What's in common? Where would you put it? On the left, right? That's what we're doing right now. What's in common, we're putting that first. And then what's left, we're putting to the right. Okay? Do you have to? The answer to your question simply is no, doesn't matter. Logically, though, it's illogical to put the x plus 6 second based on what you've been taught over the years. If you've never done it before, why do you want to start now would be my question. Good question, but you should take out what's in common in front. Okay? For your notes, you're going to want to write this down. If the third term is negative, you will always have to factor a negative out of the second parenthesis. If the third term is negative, you'll always have to factor a negative out of the second parenthesis. And when you group the first two, that's easy. Make sure when you group the second two that the negative stays inside the parentheses, in this case with the 9. If the third term is negative, just make sure the parenthesis goes to the left of the negative. I don't want you to think I'm multiplying now. I just want you to see this as being grouped, but it's not. Yeah.
So it's basically 3c, or c to the third plus 4c squared plus a negative number c minus 36.
Right. I just want you to put the parenthesis to the left of the minus. Put the parenthesis to the left of the minus. What's in common in the first parenthesis? C squared. C plus 4 is left. If the third term is negative, you must factor a negative out of the second parenthesis. So in this parenthesis, you're going to factor a minus 9. And you'll be left with C plus 4. Look and see. Everyone's seeing that? If you don't take out a minus 9, and you take out just a plus 9, you're going to have negative C and minus 4, which won't be the same as this. That would be that. Just fluffing you do back there? Everybody good there? So when you take out the c plus 4, what's left? Minus 9. It is. No, it is factorable. Okay, we gotta work on completing the sentences now. When you do a sum or difference of two cubes, the trinomial will not be factorable, ever. This is 4 terms. It is not a sum or difference of the cubes. We're just factoring. And when there's 4 terms, we factor by grouping. Okay? And when we took out the common c plus 4, we were left with c squared minus 9. And how does that factor? C plus 2, C minus 2. So C plus 4 is here. C plus 2, C minus 2. 3. You're messing with me. Only the sum and difference of the cubes is the trinomial not factorable. This isn't one of those. You will need this when you're graphing polynomial equations in polynomial functions. It's one of your options for factoring. It's not always going to work for you, but if this were a function, you'd have a 0 at -4, a 0 at -3, and a 0 at 3. And it is a cubic function, so you know all your zeros, you know the leading coefficient, your graph is going to be nice. But you got to be able to factor it or find the root somehow, and this is one of our bag of tricks. Okay. Now, the last one I want to show you on factor by grouping. When you group here, it appears that nothing is in common in the second parenthesis. But you have to factor out what in the second parenthesis? If nothing else, a -1. Here, we're going to take out a 25 and a p squared, and you're going to be left with p minus 1. Here, you have to pull out a -1, and that's going to give you p minus 1 also. The p minus 1 comes to the front, and 25p squared minus 1 is in the second spot. So if there's nothing, it appears that nothing's in common, you may have to factor a -1, and if this was a plus p, you would have to try factoring out a positive 1. What were you going to say? Really? You had nothing to say about that problem. You're good with that? And how is that factor? 5 p plus 1, 5p minus 1. 4 should do it my way. It doesn't matter the order. But I do plus first, minus second, because the minus sometimes you can factor again. Okay? Question on that? No? Okay. Alright, so this one is not a quadratic. It is a binomial. It is a difference of 2 squares, and you may or may not recognize that. And whether or not you wish to write it in quadratic form, that's going to be up to you to factor this. For a difference of 2 squares, you can do that or not. It doesn't matter to me. This is x squared. squared minus 6 squared. So if you can recognize it as a difference of two squares without rewriting in quadratic form, that's fantastic. How does this factor? I'm going to go plus first, and x squared minus 6 second. Now again, it didn't matter on this one which order you did it, but I will tell you this, the sum, the plus, will never be factorable, and sometimes the minus is. If this were an 81, this would be a 9, and this would be factorable, x plus 3x minus 3. But if the sum will never be factorable. Okay? So this is as far as you go. The other way to do it when it's not quadratic is to turn it into a quadratic. You could say, let's let z equal x squared. Let's pretend that z is x squared. If z is x squared, and I wanted to rewrite this problem with z's, how would I rewrite that? So this would be z squared minus, and it's still 6 squared. So it factors to z plus 6 and z minus 6. The difference of two squares, it's obvious. But we don't really care about z's. We would then substitute in for z x squared. And you get the same thing. It's not that revolutionary, but it might be helpful for you in the next set of problems that we look at to do that. Depends on who you are. Depends how you are visually. All right. This is the difference of two squares. Okay. This is the difference of two squares. This is a trinomial. This trinomial is not quadratic. It's quartic. The degree is 4. So if you wanted to let z equal x squared, we could write this as z squared plus z minus 20, and then you could factor. What I will tell you is the power on the first term, if it is double the power on the second term, you're in quadratic form. And the second term variable to whatever power is there is what's going to go in the first spots on your binomial. So this is going to be x squared plus 5 and x squared minus 4. That's how this will factor. Just like this would factor to z plus 5, z minus 4. And then we would replace the z's with the x squareds. Some people really prefer doing this. You let c equal whatever the variable to this power in the middle is, and then you work that problem out. And a lot of people find that to be the best way, the safest way for them to go. Others just say, look, this power is half of this, I'm good to go. And then to finish this off, how would I factor? X plus 2 and x minus 2. It doesn't always have a third factor, but you can certainly do that. And this will be, if this is a 10 and this is a 5, it's still going to work. I think we have one of those here. Here's a 3 and a 6. So for me, we could do guess and check on this one. Okay? We could do 6 and y, or 3y and 2y. It doesn't really matter to me. So you guys have to make the decision. If you'd rather do borrowing from the clouds, you can borrow from the clouds. Let's say you did 3y to the third, 2y to the third. Okay? 3y to the third and 2y to the third. We can try that. And then we would have to use either a 1 and a 4 or a 2 and a 3. If we did a 1 and a 4, you could put the 4 here and the 1 here. And that's going to give you 8 and 3. This would be the minus, this would be the plus. So that's guess and check. to get the factorization. No, I guess and check. I can do it with borrowing from the clouds also. We can also say, let's let z equal y to the third. And if we let z equal y to the third, you'd have 6z squared minus 5z minus 4. And I know for a lot of students, they look at this and they go, I'm so much more comfortable with this than with this. And then they might do borrowing from the clouds. You get a negative 24. Factors of 24 that subtract to 5. What would you get? So 3 and 8. And the 8 would get the negative, the 3 the positive. So 6z plus 3 and 6z minus 8. What's in common in the first parenthesis? So you'd be left with 2z plus 1. And in the second parenthesis, 2. So you get 3z minus 4. And then you would replace the z's with the y cubes. 2y cubed plus 1 and 3y cubed minus 4. Same thing we got on guess check. Better be. Okay? Can we factor 2y cubed plus 1? Yeah. Oh, it sounded like you sprung a leak there. Never mind. I'll explain them all. Is this a sum of the cubes? Something cubed plus something cubed. Why not? Take the 2 away and then would be good. If we had an 8, would be good. If we had a 27, would be good. 2 is not a perfect cube, so that can't be factored any further. Same with the 3 and the 4. So this is how it factors. Any questions on factor by grouping, quadratic form? These things take time and practice and repetition. If you aren't one of those people who is doing this, don't just set your sights lower. Don't feel like you're going to master it because you're not. I'm telling you, you've got to be very diligent about this homework. And we get a million examples here. The next thing is solving the equation. So we factor. Why do we factor? We factor to solve. N to the third times n plus 6 is equal to 0. So you factor what's in common first. Then what do you do? Yes, what's that called? Zero product property. Once you have something times something equals 0, set each of them equal to 0. So n is going to equal negative 6, and n is going to equal 0. Now there are 4 solutions to this problem because the problem is degree 4. It looks like we only found how many? 2. This is n to the first plus 6 equals 0. So n equals negative 6. That's called a single solution. This is not critical for you to know today, but I'm setting you up for later. It is n to the first, so that's a single. This was n to the third, in which you cube root both sides. So you got n equals 0. Because it's n to the third, that's a triple solution. Again, this is a detail that you don't need to know today, but since we're here, why not just say, hey, triple, single. All together, a triple and a single, 3 plus 1, 4 solutions. Okay? But again, you don't need to worry about that right now. This problem is perfect for me to show you next, so that I can show you what you shouldn't do. Okay? Can someone tell me what you might be tempted to do or what you may think is a correct thing to do? Christian? We had some equals in between there, dude.
Yeah, exactly.
But in order, no, I want to know how to solve this. What might we do on this problem? There's lots of paths you can take. Some of them are wrong. It's mathematically correct, but it's not a good idea, and I'll show you why. What else could we do?
Dividing side by side.
You could. You could divide both sides by 9k squared, which is going to give you 4k over 9 is equal to 1, right? And then what would you do? Multiply by 9 over 4, and k is equal to 9 over 4. Okay? And mathematically, perfect. Okay? Mathematically, it's perfect. However, if you look at this, the highest power on k is a 3. You should expect 3 solutions. We only found a single solution right here. What you can't do is divide by a factor, a variable factor. Because when you do that, you're going to lose roots. You're going to lose solutions.
In these types of problems where there's no constant, you just say that x is zero because there is no constant.
You can, but you still need to show me the math. So I'm more concerned. My honors kids really struggle with this in the second half of their class. They're obviously not there now. But the same things are going to apply to the trigonometry that apply here in the algebra. What you want to do is set it equal to 0 first. That should be your first goal always when you're solving these algebraic equations. Get a 0 on one side. And make sure that the term with the highest power is positive. We want this to be a positive. I don't know. So now we go back to what Christian suggested. What'd you say? Which is k squared. If we pull the k squared out, you'd be left with 4k minus 9 equals 0. And then if you set each factor equal to 0, you're still going to get k equals 9 over 4. And here you're going to get k equals 0. This is a double. Did I make a mistake? This is a double. This is a single. Together, that's 3. And that can help you know that you got the right number of solutions. It doesn't always work, though, I'm telling you right now. Because sometimes you're going to get only one solution, and the other two solutions are imaginary. So be it. Nothing you can do right now about that. Okay? Again, we want to start equal to 0. How would you solve this one? Group it. How do you know? 4 terms. Group them. First two, last two. How do you solve this? Group them. How about this one?
Oh, actually, first.
This one's in quadratic form, so you can either substitute and substitute that, or you could recognize, hey, it's going to be y squared minus 9 and y squared minus 5 equals 0. And y squared minus 9 equals 0. You can solve it like this without factoring. What would y equal?
Plus or negative 3.
Plus or minus 3. Here, you do the same thing, but you're going to get a radical solution on this one, and just leave it root 5. I don't want decimals for that. Okay? This is where you're going to be tonight. This is a minimum assignment. Okay? If there's areas that you're weak in, and if you just blow through this, boy, it's not going to be good. Your homework from last night on your way out needs to go on this table in a nice neat pile.
Oh, it's all.